Ever wondered how an AI can crush a chess grandmaster, or how your GPS just knows the fastest route, like instantly? Well, it's not magic. It's actually a super powerful, methodical process called search. So let's pull back the curtain and see how an AI actually thinks its way to a solution. At its heart, pretty much any problem an AI has to tackle is really just a big puzzle. It doesn't matter if it's navigating a city or winning a game. The basic challenge is exactly the same. How do you find the right sequence of moves to get from where you are now to where you want to be? Okay, to really get this, let's picture our AI as a little hero on a quest, say trying to get through a maze. Before it can even think about moving, it has to understand the rules of the game. And it turns out every single search problem really just boils down to three key things. First up, you've got the initial state. That's just the starting line. Where is our hero right now? Second, the actions. These are all the possible moves it can make from any given spot. Go left, go right, up or down. And finally, the goal state, the finish line. The AI needs a way to know, hey, I did it. I solved the puzzle. Now, if you take every single possible position in that maze, every single intersection, every dead end, all of it, that entire collection is what we call the state space. And the AI's whole job is to explore this giant map of possibilities to find one good path from the start to the goal. So, how on earth does it decide which way to go first? Well, let's start with the simplest approaches. These are called uninformed or blind search strategies. Just imagine our hero is dropped into that maze with zero information, no map, no compass, nothing. All it can really do is just systematically explore, hoping it eventually stumbles upon the exit. We can actually give these strategies little personalities. On one side, you've got breadth first search. Let's call it the cautious method. It explores step by step, checking all the neighbors before moving on. It's guaranteed to find the shortest path, which is awesome, but man, it can be a real memory hog. On the other side is depth first search, the reckless method. It just picks a path and goes for it, diving as deep as it can. It's super fast and doesn't use much memory, but it might get stuck down a really long, useless path and completely miss a much easier solution right near the start. So here's the catch. These blind strategies, they'll get the job done eventually. But they're not very smart, are they? They're just wandering around without any sense of direction. Which leads to the obvious question. What if we could give our hero a little hint? What if we gave it a compass that pointed roughly toward the goal? And that right there is the leap to informed search. This is where our AI gets a kind of superpower, a way to make an educated guess, to help it figure out which paths look more promising than others.
And that superpower has a name. It's called a heuristic. A heuristic is really just a fancy word for a rule of thumb, an educated guess that estimates how far you are from the finish line. Think about it like this. When you look at a map, the straight line distance to your destination isn't the actual driving distance, right? But it's a pretty good guess. It helps you know you're generally heading in the right direction. That's a heuristic. Which brings us to the rock star of informed search algorithms, A*. What it does is absolutely brilliant. For every potential path, it calculates a total cost by adding two things together: the actual cost it took to get to this point, plus the estimated cost to reach the goal. That's our heuristic. And that's the genius of it. It perfectly balances what it knows for sure about the past with an intelligent guess about the future. By always exploring the path with the lowest combined score, A* is both incredibly smart and systematic, and it's guaranteed to find the absolute best solution. At this point, you might be thinking, okay, this is cool and all, but why all the fuss about being so efficient? Can't a supercomputer just check every single path? Well, for a tiny little maze, yeah, sure. But for the problems we face in the real world, the scale is just mind-blowing. Just take the game of chess. The number of possible legal positions on a chessboard, that state space we talked about, is estimated to be 10 to the power of 120. That is a 1 with 120 zeros after it. It's a number so ridiculously huge that it's bigger than the estimated number of atoms in the entire known universe. Trying to brute force a solution here isn't just slow, it's literally, physically impossible. This is why we need smarter ways to search. But what happens when the puzzle starts fighting back? I mean, in games like chess, you're not just solving a static problem. You're up against an opponent who is also trying to find their own path to victory. This completely changes the game, and it's called adversarial search. To handle this, AIs use a really clever strategy called minimax. The idea is actually pretty simple. The AI is the max player. It wants to maximize its score. The opponent is the min player. They want to minimize the AI score. So the AI looks a few moves into the future, and for every single move it thinks about making, it assumes the opponent will make the absolute best, most devastating countermove possible. It's basically a calculated pessimist. It then picks the move that gives it the best outcome, even in that worst-case scenario. So look, this isn't just about fun and games and mazes. These search algorithms are the secret engines running behind the scenes of technology we all use every single day.
And the impact is just massive. Every time your GPS finds the fastest route through traffic, that's probably A-Star Search working its magic. When Amazon figures out the most efficient delivery route for a driver, or when an airline schedules thousands of flights around the globe, those are colossal search problems. And those robots you see in warehouses, they're constantly solving search problems to navigate without bumping into things.
And of course, it's all over our entertainment. That AI opponent in your favorite video game that always seems to know your next move? Yep, probably using a version of Minimax. When characters in a game run around a complicated world without getting stuck on a tree, that's search. It's what makes our digital worlds feel so much more alive and intelligent. So, the big takeaway here is that whether an AI is exploring a simple maze, a chessboard with more possibilities than atoms in the universe, or the very streets of your city, the core idea is exactly the same. It is all about methodically searching through a space of possibilities to find the best path to a goal. It's a fundamental building block of so much of our modern world. This technology is incredibly powerful at finding the most efficient way to achieve a very clearly defined objective. And that leaves us with one last really important question. As this tech gets even better and even faster, what are the most important goals we should be pointing it to next?